All right. So this week is loops. If we take a look at our schedule just to see where we are. It's good to look at our schedule once in a while here. Okay. So this week we're going to go over looping. Okay. And we'll look at our homework in our lab in a second for our loop section. So this is our chapter 5, looping. Next week we're going to review. And then the following week is our test 1, which is a multiple choice test you take in here in person. Okay? And next week, remember to study for next week's review, because I'm going to have a Jeopardy review on next Wednesday, and all those points that you get in Jeopardy review go toward your test. So make sure you study for the review. And a way to study is you could study those quiz questions. In fact, I meant to post another quiz. I'll post the quiz for chapter 4 and 5 by tonight. Okay, and then you can study all the quiz questions for all those chapters. Should be good. I was just kind of eliminating some of the other questions from the 4 and 5 and not just throwing the whole test bank up there. Yes, question?
Is the test Scantron?
Yeah, I think I'm going to do it Scantron. I'm debating in my head whether to have it in Blackboard or Scantron, but it'll still be multiple choice true false. And I bring extra Scantrons. And I never make test 1 more than 50 questions, so it'll be probably 50 questions. Okay? And it's, just on what we've learned in chapters 1 through 5. It'll be similar to your lab questions and similar to those questions in the test bank. Okay, the ones that are correct. All right. But let's go ahead and start in on loop. Well, actually, let's look at your homework. Sorry. Let's go look at your homework over here. And then we'll do our lecture. So, I gave you guys a loops lab. And in the loops lab, you do have code blurbs inside of it. And I am going to give you some time next week to start in on this lab. I'm not going to give you, we probably won't have time today to start it. We might. But remember that for these code blurbs, I no longer write the entire program out for you anymore. So you would copy and paste these code blurbs into a working program. Okay? So I think we've gotten to the point where, you guys are... you know enough that you can actually copy and paste some code into a working program and have it work. Okay? So I no longer write out the whole program for you. And just like your other labs, you test code, then you answer the question, okay, in your own words with a complete sentence. Make sure you answer the question. All right? And remember that one isn't due until Wednesday, February 24th, so I'll give you some time on Monday to kind of work on it. You can start in on it early, but we'll give you time on Monday to work on it. Okay? And then I gave you a programming problem, and this is just a programming problem that involves a loop, of course, since this week is loops. And it's to write a program to read a list of exam scores given as integer percentages in the range 0 to 100. Kind of a typical kind of looping problem. You'll see this in a lot of books, actually. And we'll do a program today that's similar to this, and one on Monday that's similar to this, so you'll know how to kind of create a program like this. And I didn't make it due until Friday, February 26th, so you guys have more than enough time to kind of work on this guy. Okay? But pretty much this will be your input. And then this is what your output is. So it tells you how many A's you have, total number of grades. It tells you how many A's you have, how many B's, C's, D's, and F's you have. Okay? Given those scores. Right, so just like, a summation tool. And then I put your readings up here. Okay, you should probably already have read this, but remember that we've made it up to chapter 5. Okay, and then also I put the extra credit problems assignment in here. Someone asked, hey, if I do more problems in the book than are required of me, can I get extra credit? Sure. I think if you want to program more that makes you a stronger programmer, that's great. You can upload, your extra programs here. I'll give you credit for them. Of course, the harder problems will get more credit than like an easy problem. Okay, if it's really easy, then yeah, you're going to get like a point of extra credit. And if it's a harder problem, you can get a few points. Okay, so, but you can upload them to that assignment there. Okay, and you can always ask me, even if it's not an assigned problem, you can ask me if you get stuck on those extra credit problems. Okay. For your lab on strings, I think I'm going to wait until next week to go over your strings lab after I've graded them. And then your other homework problem, I've had a couple people ask me about this problem, and I think we're going to go over both the strings lab and this homework problem on Monday. Because that way, at the end of class today, I told some people, hey, why don't you bring up your program, we can look at it again. And yes, it will be counted as late if you turn it in again, but if you didn't get it working, it's better to turn in a late working program than a non-working program. Okay, so you can bring it. We'll give a little bit of time at the end of class to look at those. Okay, and we'll go over those on Monday, which will be good because that'll be the beginning of our review week anyway. All right. Okay, so that's all that. Any questions on our homeworks? Okay, good. If you have questions later, remember to ask me. So we're going to start in on our loops lecture. Wait, question, yes? Yeah, so any problem in your textbook? Yeah. And you'll just tell me which one it is. And then I might ask you about it to make sure that you wrote it and stuff. But just remember that I could ask you about your programs, okay? So make sure you know you're writing all your own programs.
And how much extra credit are we looking at?
I should put a cap on it. We'll make it like a cap of like 20 points total. That would be like 2 assignments.
So we can add to the test?
Mm-hmm. Well, no, it would add to your homework points.
Okay.
So like
add to your programming problem.
questions, write a loop that can be used in Java alphabet to draw the following row of identical circles?
Yeah, you can do any of them.
Okay.
Yeah, you can even do the graphical problems. Yeah, that was a Java applet problem.
Is that like the whole semester or for each?
Yeah, I should think about that more. We'll do these extra credit up until test 1, and then we'll make another 20 points, I guess, after test 1 to test 2. That sounds like a good idea. All right, I'll have to write that in there. Thanks for asking those questions. I will clarify in there. Okay? So good. We'll answer that question later. Okay. Good. So today we're going to talk about looping. All right, so we've learned about statements. Statements are how we declare variables and how we output things. It's just one line of code that runs, and that's what it does, right? We make a variable equal a value. That's a statement. And then we learned about branching. Branching helped us make decisions in our programs. We had the if and else if. We had our switch statements. But they all just moved down in our code. We never moved back up in our code. And the last kind of logical structure that we're going to learn about is loops. And with statements and branching and loops, you can write any program in the world. That's all there is to it. Right? Then we add another level of abstraction called object-oriented design, which helps us write it a little bit better. But it's the same logical constructs in object-oriented design. So these are actually the only logical constructs you can have in a programming language are statements, branches, and loops. Computer really can't do all that much. It is just a binary adding machine. And so the logical constructs we can do are statements, branching, and loops, and that's it. Okay, so once you learn, up to chapter 5 here, you've pretty much learned the basics of all programming languages. Okay? All right, so let's look at loops. Loops in Java. Okay. So a loop is a portion of your program that repeats a statement or a group of statements. So it's a way to go back up in your code to repeat a certain part of your code over and over and over again until you tell it to stop. Okay. The statement or group of statements to be repeated is called your body of your loop. An example of a loop would be to compute grades for each student in a class. That's a common one. Or like your homework problem, to total up grades. And there must be a means of exiting the loop. So that's the big thing. You know, if you don't exit your loop, what happens in your program? It keeps going and going and going. And in graphical programming, that's what we want to happen. But in regular console programming, we don't want it to keep going like that. Okay? So in Java and most programming languages, there's 3 different types of loops. There's a while loop, a do-while loop, and a for loop. And then there's a different version of the for loop called a for each loop, which we don't really use until we get to arrays in here. All right, so let's look at a loop. A lot of times we describe our code using these things called flowcharts, and in a couple of your labs we've used flowcharts. So just to kind of recap on what a flowchart is, this is a flowchart. The way the flowchart works is we put our statements inside of rectangles, and rectangles just do one thing. They have one arrow, well, they can have multiple arrows in, but only one arrow out of a rectangle always, because it is not making a decision. It's just doing something, so only one arrow can ever come out of a rectangle, right? Diamonds were our decisions. So diamonds always have a true and a false case. You don't want to have a diamond with one arrow. You want to have a diamond with 2 arrows. Okay, the true case and the false case. Okay. And then remember that whenever you're working with a flowchart, there should be a way to go into your, and then there should be a way to leave your flowchart or end your flowchart. All right. So this flowchart here shows how loops work, and then I put the code up here to kind of show you, what was going on with our code. So we see it pictorially and then syntactically with our syntax up here. So this is a while loop. A while loop is considered a very easy loop to create. Okay. This computer's been having this problem, but we'll take care of that in a second. So in this loop, you can see the beginning of the loop has a while statement. Okay, it's followed by your parentheses, which has a Boolean statement in the parentheses. So it has a true or false or a Boolean statement, something that evaluates to true or false in those parentheses, just like a branch. Okay, and just like a branch, you use the same comparison operators, less than, equal to, greater than, equal to, or equal to. Okay. And you can kind of almost see how this thing works just by looking at it. You just kind of read it. You say, while count is less than 100, execute this code. Okay, so every time that statement is true, count less than 100, you execute from the top of the curly bracket to the bottom of the curly bracket, and then you come back to the while loop to check again to see if it's true. If it's true, then it executes again. Okay. If it's false, if that the Boolean statement's false, then it doesn't execute the loop. It comes out of the loop and goes on with your code. Okay. All right. So, by looking at this code, how many times will it print welcome to Java to our screen? It starts out at 0 and it executes until that Boolean statement becomes false. So how many times will it execute to the screen? 100, yes. Okay. So because it starts at 0. And when it becomes 100, is 100 less than 100? No, and that's when it becomes false. So from when count is 0 to 99, it's true, and that's 100 numbers, because we started at 0. Okay, and in programming, a lot of times we do like to start at 0. Okay? When we get to arrays, you'll realize why we always start at 0. But a lot of times when we start counting things, programmers will start counting at 0 and not 1. Okay?
So the count plus plus that keeps on adding 1 to
Oh, yes. I thought we knew that one. Yes, so count plus plus is another way of writing this statement. Did we not go over that one? It's good to review it anyway. But it's another way of writing count is assign the value of count plus 1. So it's another way of writing that out.
Yeah, but I was asking, the count plus plus, it keeps on adding 1 to the, like, if it start with 0, then it add 1 to 0.
Yes.
0, 1 to
In
0,
fact,
0,
I
1.
think my next slide's here. Yeah, let's look at this one here. So I've changed the number till 2. Actually, this slide came with the book. So he changed the number to 2 to kind of go through what it's doing step by step. And it is good to realize what your loops are doing step by step. In fact, I'm going to show you a technique that you can use to draw out a table so you can start visualizing what these loops are doing. Okay? So, you know, count is a cup in memory. It starts out with the value of 0. When you get to this line in your code, you know, count, it checks this. It plugs in the number. 0 less than 2. True. Okay? So if it's true, it comes into it drops into the loop. Okay? So it executes this line. In fact, we can go through our slides here. So it checks, says, hey, that's true. It drops into the loop. So it's going to execute from the top of the loop to the bottom of the loop in order. Okay? So it prints out welcome to Java. It adds 1 to count. So now count is equal to 1. Okay? It goes back up to the top of your loop and does the check again. So every time it ends the loop, it does this check. And it says, hey, is 1 less than 2 true? Okay. Comes back as true. It executes your loop again. Prints welcome to Java. Increases count by 1. So now count is 2. Comes back to the top of the loop and it says 2 less than 2, which is false. Remember, if you wanted it to execute 3 times, you'd put that little equal sign right there, less than or equal to, or the number 3, and you could get it to execute 1 more time. This is really important right there. What if that wasn't there? Yeah, then it will always be true. What happens if a loop is always true? It becomes an infinite loop. And do we get infinite loops in our programs? Yes, sometimes. Yes. Okay. Even in, modern programs, sometimes your program will pause, and I always think in my head, oh, I think it's entered some infinite loop in there. It keeps trying to do something without changing the variables properly, and, it never really gets anywhere. Okay? So that's our while loop. So notice our while loop has those 3 parts. It initializes the variable. It checks to see if a variable, you don't always have to have a variable check here, but this is a common way to do it. It checks the variable and then it updates the variable. And it does those 3 pieces there. Initialize, check, update, check, update, check, update. Okay? And we're going to see the same thing in our for loop. And just remember that when it does come back as false, that it goes all the way to the end of the curly bracket and continues on in your code. Okay? All right. Oh, good. I do have my try-its up here. All right. So I'm going to kind of show you a method. And I'm going to have you guys help me out here. To kind of go through loops, and you can do this with your loops in your book or loops you find online, okay, to kind of start visualizing what's going on in your loops. And maybe loops are easy for you at first, which is awesome. You can move on to dual for loops then. Okay, you can use the same technique for loops inside of loops. Okay. But what I do is I make like a chart here. Maybe I should use something other than red. Or green. All right. A lot of times, I can even label what loop I'm on, like the first loop. And you could make a column for all of your variables. So product and number. Okay. And so when I begin my loop, at the beginning of every loop, I figure out what my values and my variables are. So at the beginning of this loop, product is 1 and number is 1. Okay? So then I start my loop. And I just plug in the numbers. Is 1 less than or equal to 10? True. Okay, then I go into my loop. Product equals product times number. What does my product now equal? 1. Still is 1 because 1 times 1 is 1. Puts that value back in the product. Number plus plus. So he becomes a 2. And then I'm done with my loop. So I start the second loop. And I just bring down these numbers because that's my initials. That's the initial values of these numbers when I start the loop. And then I check it again. Is number less than or equal to 10? Yes. Okay, so I execute my loop. And this is starting to get really annoying. Okay. Number less than or equal to loop, yes. Oh wait, we're on this loop. Sorry, I got mixed up. We're on this loop. So now I need to execute my loop. So product equals product times number. So what will my product equal? 2. Yeah, because 2 times 1 is 2, and then you put the 2 back in there. Number plus plus, what will he become? 3. And I end my loop. So then I start my next loop. These are the values of my variables for my next loop, so I drop them down. I go number less than or equal to 10, true. So I go into my loop. Product equals product times number, what will it equal? 6. Number plus plus, 4. I'm done with my loop. I go and I try it again, right? So I drop down my numbers. 4 is less than or equal to 10, true. Okay. So product equals product times number. 24, good. What will number equal? And you'll start to see a pattern. Many times, and that's just computers in general, they have patterns, right? Okay, that's why we learn patterns in kindergarten, right? In loops, there are patterns because we're doing the same thing over and over again. So a lot of times when you start making these tables, you'll start to see the pattern. The pattern is kind of obvious here, okay? Right? Our number is going up by 1 each time. So if we keep on going, we could keep going here. I shouldn't have put 10 in there, note to self. That's a long one. But you just, you keep going. So what will product equal? So we know that this loop is going to happen 10 times, right? What will product equal? Oh yeah, 120. And then he equals 6. And then we go again. And just remember that when you get the pattern, that you don't rush ahead too much because sometimes we mix ourselves up. So you still execute in the same order, okay? And then let's see. You guys have to use a calculator now, maybe. That'll be 14. What is that? What is that? You guys tell me. 1540?
Yeah, 50-40.
50-40. Oh, wait. See, I got mixed up already.
That's nice.
So you can't get ahead of yourself. Remember that in this loop, he equals 50-40, right? And then here, he equals the 8, and then I drop him down. Okay. So sometimes when we find the pattern, we start rushing through. I do that too. Okay. And 8 is still less than, 10, less than or equal to 10, so we're still going.
40,320.
Okay, and then he becomes a 9.
362,880.
Good job, yes.
But that's false though, right?
And then he becomes, wait, no, he dropped down as a 9. Sorry, I didn't drop him down. He was a 9. Because this one was 40,320, and then I crossed him out, okay? All right. And then he becomes a 10.
Which that's false.
So, 3,000,000.
Actually, it's true, because less than or equal to 10.
Equal.
Yeah.
Okay.
And so,
3,628,800.
and I remember why I did this, actually. So that we could see that in loops, our numbers can get really big really fast. Okay? They can get really big really fast because we're doing the same thing over and over again. Okay? But note, that's kind of a technique we use, and I have some other try-its that we'll try this out with. But, you know, seeing the pattern helps. Writing down each loop, not getting mixed up on what loop body you're on. Okay, which loop execution cycle you're on.
Oh, if you do a system printout of product, it'll give you the last that 7%.
Yeah, that's another technique you can use when you're doing these things. You can even double check yourself. I do promote writing it with your hand, yes, actually writing it. But you could do system out print lines. He said, hey, I system out printed line. So you can do, you know, a sys out right here of product and a sys out of number. And you could see how they're changing in your loop on each loop execution. That's a way to kind of check yourself. Okay. And after we start visualizing how these loops are working, it does make complete sense how they're working. Okay. Okay, cool. So that is our while loop. Okay, notice some things about the while loop you'll see in the for loop too. We do the initialization action once. Here's where we do our check each time. And this is called our update action. Okay? Actually, let's try this one out. So, what I usually do is I don't stand up here and write them all the time. So you guys are going to help me write these out. I should have brought my candy today. Got my candy. Oh, okay. So we have count. I'll do the first one. We have number, and we have value. Actually, I do want to change it eventually, but I just need it's kind of messed up right now. Okay. Okay, so we have count, number, and value. When we first enter our loop, count is 1, number is 10, and value is 0. So you check to see if you actually get into your loop. Plug in your numbers. Is 1 less than or equal to 10? True. So we know we're going to execute the loop body. Okay. And so we have this if-else statement in here. What does count modulus 2 do? We've gone over the modulus operator, I believe, right? Yes, the remainder operator. Okay. So when you modulus something by 2, what is it checking? Remainder if you divide by 2. If the remainder is 0, what does that tell you? It's even. Yes. If you divide something by 2 and there's no remainder, it means he's even. And if you divide something by 2 and there's a remainder, it means he's false. Because your remainder can either be 0 or 1. All right. So note that that's what that's doing right there. And so if count modulus 2 equals 0, value will go up plus plus, else value plus equal 5. So we plug in the number here. 1 modulus 2 is 1. Equals 0 is false. Because 1 does not equal 0. So it's going to go to the else part, else plus a value plus equal 5. So what's going to happen to my value? Yep. Okay. And then count plus plus. And I start my new loop. Remember, when you start your new loop, you just drop the value of your variables down a row. All right. Who wants to do the next loop? And I'll remember candy next time, and you get a candy next time.
So, count is less than the number, and the count is 2 now, so 2 divided by 2.
Yeah, see, you're already doing it. Here.
Oh, no.
No, you get to draw up there. So you get to do loop number 2. So stay in row 2, and then you get to pass it off to somebody else. See? In fact, I'll even put this thing over here.
What about deer in the headlights?
That's okay. And then we can help each other. Don't be afraid.
So 2,
So you just check. So what you do is you plug in the numbers.
and there's no remainder, so it's,
So you've already done the first part. She did the first part. 2 was less than 10. True.
right, so it has no
So she
remainder,
plugs
so
them
it's
in.
value plus,
So yeah.
I
So
mean,
it'll be 2 modulus 2 equals 0 is true. So value plus plus.
so value plus
Oh,
1,
Yes.
right? So it's,
So write it in the same row. You'll cross out the 5, and you'll write a. Good. See, we can help. It's like Price
And-
is Right.
the count is...
Count plus plus. So you'll cross out count, stay in that row, and you make him a 3. So when you're in that loop body, remember to stay in the row that you're in. And then when you're done with the loop bodies, you are done with your loop
Is
body.
number still 10?
it's
Number
still
is
10.
still 10. Number stayed the same. Yes, good. Now you just drop your numbers down. So after you finish your loop, or you can even leave that part for the next person, but that's what your numbers will start out with for the next loop. Yay. It's good for us. It really is. All right. So he does, he checks. You plug in the numbers. 3 less than or equal to 10, true. So then you plug in your numbers. 3 modulus 2 is?
That's 1. Okay.
1 doesn't equal 0.
Yeah.
So it goes to that one.
So
Value plus 5.
so it's value plus 5. That's
Yes.
11.
Remember to write in the same row.
Oh, same row.
Yes.
That's a 6.
And if
then
you
11.
follow this, and I know these are easier loops, so you know that the next value is going to be 11. But if you stick to kind of the methodology of staying in your row when you get to harder loops, it'll help. Okay. Good. Good. Excellent.
Yeah.
And we can start to see the pattern now. Okay, you can almost start to see the pattern here. All right, so he wrote the numbers down for you. Fine. Let's say yes. Okay.
Wait, I can't see.
So you just plug in your numbers for count and number. So 5 less than 10 is true.
So yeah. So you add 5 to this, right?
So let's see, you plug count into here. Oh yeah, so add 5. Good, you're already ahead of me. Good. See, he already knows how to do the pattern.
Ready?
Wait,
How did you get...
No, it's not really not that bad.
Did you add 5?
Oh, but let's see here. So she had a question. So back up. We're backing up. So let's see. We're in this row, right?
Yeah.
So he plugged in 4. Oh, did he do the wrong one, huh?
Did I?
Because 4 modulus 2 is 0. 0 equals 0, so value got a plus plus, not a plus 5. And so the pattern is it adds 1, it adds 5. It adds 1, it adds 5.
So it's 12. Okay.
We didn't even catch that. Good job. So put 12 right there. Actually,
11.
cool. We fixed him.
Perfect.
And everyone saw that, right? That was good. It's good to make mistakes and we can see. That was good. And this is why we do our loops, and this is why we write them out like this, actually. It helps us to kind of see what's going on there,
So we'll just drop
see our
it.
patterns. Yeah, and then you drop it for the next loop. Good. Excellent. And we're almost done with this guy. Let's do a couple more. And you can tell how many times this loop is happening, because if you look at, how our initialization action, what we're checking, and how we're updating, this loop will happen 10 times. Okay, it executes 10 times.
The 18?
It is. Now you should have done it in order, but yes, that is right. Because it plugs the 6 in here. 6 modulus 2 is 0. 0 equals 0. It does add 1 to value. So good. But after you see the pattern, now that we know what the pattern is, it would be very easy to write down our other loops. In fact, maybe I'll cut this one short and we can write down our pattern. Okay, good.
Is it right?
Yes. No, that's right. It came down 1. So our row is like this. It's okay. Here, let me write the rest of the pattern, then we'll do some more loops. We got some more loops going on. Okay, but we see our pattern now. What's our pattern? What's this guy going to be? When he's even, he adds 5, right? When he's odd, he doesn't. So you can start to see your pattern here. So then he's gonna change to a 24. He's gonna change to a 9. And 10 always stayed 10. Then he's gonna change to a 29. He's gonna change to a 10. And then what does he change to at the very end? Because do we execute one more time?
No. Yes.
Yes. We do one more time because we have the less than or equal to. So then what will he be at the very end of this loop? And what will count equal at the very end of the loop? He'll be 11. Okay. So after you start seeing the pattern, sometimes you can skip ahead like this. Yes, that's okay. But I think there is benefit to writing it down like this and not just doing system out print lines. On Monday, I'll show you the debugger, too, and we can look at our values of our variables that way, too. So we kind of got, starting to understand while loops. I know for some students, it is kind of a struggle at first to kind of understand what's going on, but I think writing down helps. The more you look at it, the more it makes sense what's going on in there. Okay? And if you're understanding loops, great, because this is our last kind of logical construct here. So that's our while loop. Okay. Our second type of loop, it is considered a separate loop, is a do-while loop. So I want you to look at something first, though. Look at our flow chart here. So notice in our flow chart for a while loop, we check. And if it's true, we execute. We do the check first, and then we execute. Right? For our do-while loop, notice that they're switched. We execute, then we check. So in a do-while loop, you execute the loop body, and then you do your Boolean check. A do-while loop looks like this. You put the word do, you have your curly brackets, and then at the end, and usually we write the while right next to the curly bracket. Okay, it's customary to do that. We'll say while, and then your Boolean statement in the parentheses. It's the only loop that'll have a semicolon at the end of the while statement. The other loops don't. And it won't give you an error when you put semicolons at the end. It just will be an endless loop if it's true. I'm sure we'll have some of those.
So a while does it.
A do-while, you have to execute at least one time because it doesn't do the Boolean check to the end. Where a while loop could actually happen 0 times. If you do your Boolean check in a while loop and it's false, he'll happen 0 times. If this guy was false, he'll still execute at least one time. So that's the difference between a while loop and a do-while loop. A do-while loop has to happen one time. So it does the check at the end, but it works the same way. Okay, so it still works the same way. Should we try this one? We should try this one. Try this guy out. I tried to pick funner variable names for this one. I think I was hungry at the time. So we have our hamburger. Fries. Coke. And then we have our order. Hamburger is 50. And fries is 10. Coke is 0. And orders are 0. Okay. Okay, if it takes too long, we'll cut this one short. Alright. But I tried to put some, other kind of code in here, like the minus equals and plus equals, so you can remember things. Now remember, on loop 1, we don't do the Boolean check first, we do it at the end. So, well, on all the loops, we do the check at the end. So hamburgers minus equal to, what does hamburgers equal?
48.
Good, yes. Remember that's elongated. The long version would be hamburgers equals, or hamburgers is assigned the value of hamburgers minus 2. Okay, so it's pretty much just subtract 2 from hamburgers. That's what that means. All right, then we have an if statement. You plug in the numbers. Is 10 less than 48?
Yes.
True.
So
So we add the value of fries to Coke. So what will Coke equal?
10.
Okay. We skip the else part because the if part was true, so we skip the else part. Fries plus plus. And I didn't even use the value of orders. That's why it was...
So orders is in the else.
Oh, okay. Sorry. Yes, there he is. We do need him. All right. So then at the end of the loop, I do my Boolean check to see if I'm going to go on. Okay, is hamburgers, so plug in hamburgers, 48 greater than or equal to 10? True. Okay, so I know that I'm going to execute my loop again. I bring my value of my variables down. And who was next? Dun, dun, dun. Hopefully you're paying attention.
I kind of was.
You got it. And we can help him. Okay. So we've already done the Boolean check for you, so you know you're going to execute your loop.
I was not paying attention.
Oh,
So,
oh.
Hamburgers minus 2.
So do this one.
So hamburgers is 48 now, minus 2.
So it's 46.
Yes. Good.
Okay.
And then execute your code, so plug in your numbers.
Fries.
So 11 less than 46 is true.
12.
So you add the value of fries to Coke.
Oh, I made fries to
So
21.
21. All right. And then we skip the else part. And then we add 1 to fries. And then we do our Boolean check. So you plug in your numbers. You plug in hamburgers. 46 greater than or equal to 10, which is true. So we know we'll execute the loop again.
So I
So
just
you can write down the numbers for the next person if you want. We know the loop is happening again. Good. You can hand it off to somebody. You get to pick the next thing. We need to start in the back. So next time you have to go back to there.
So hamburger minus
So we've already
2.
done our Boolean check. So she's already jumping in good. She was paying attention.
Okay, and if fries is less than hamburgers, so
Which is true.
hopefully I'm adding right.
Yeah, that's true. Good.
And then add 1 to fries.
Good. And And then you can do the Boolean check at the end if you want. So you just plug in hamburgers. He'll be true for a while. And you can start to see a little bit of a pattern.
I guess I'll go straight into the back room.
Yeah, you can go to the back row. And next time I'll bring some candy. Just remember who went. And then, I usually help alleviate stress.
Take this for like a candy day.
Yeah, I know. I have it in my office actually. Should run out of it. Okay, good. So he jumped right in because he knew, the loop would execute again.
Right? 46?
Yes, good. And now you're here in your code. Good, excellent. And then he knows he's going to execute again because he knows, hamburgers is still less than or equal. Good. Let's go a couple more times. Eventually we are going to get to the else part. You can hand it to somebody. And if this is easy for you, good. Okay. And then, we'll look at a dual for loop, and we'll see how this can help us with that too. It's recording. That's good. Good. I think she did it right?
Yeah, add right.
Oh yeah, because it
60.
Yeah.
It's 60.
went. Okay, yeah. Good. Excellent. And you can hand it to the next person.
The hard part.
Actually, fries will always be less than hamburgers.
Because you add 14 to 43.
I should have put Coke
Oh,
in
that,
there.
okay.
I just make these random.
I think the hard part is thinking up something to operate like this on your own.
Oh, I know. And this is kind of just,
75.
this is kind of silly code a little bit, but it kind of proves the point. I mean, it's not really actually doing anything useful. But good. Did you do it right, guys? I didn't even check. Oh yeah, you can drop it down if you want. Because hamburger is still less than 10. I mean, still greater than 10. And you can see we're going to go on for a while, so maybe this is a good place to actually stop this one. How many times will this execute, actually?
A lot.
Well, we're only subtracting by 2.
When hamburgers is
He starts at 50 and he goes to less than 10, so how many times will that loop execute?
No, wait. Yeah.
So he's 2. So he'll go until he's 10. So 40 divided by 2, yeah, that'd be 20 times. He should go about 20 times. Oh, and we can stop there.
Just went. I just
But check to see that his is right.
went, man.
Is his correct? I think it's right. Yeah. I think it's a good place to start. It will go on. I note that you could write it out more. But this is a good place to stop this one. Okay. So, all right. So notice that a do while loop happens just like a while loop, but you do your check at the end. Pretty easy. It still has the initialization action, our update action minus equal to, and then our Boolean check. All right. So let's look at another kind of loop. So we have while loops, do while loops, and this is our last type of loop called a for loop. And a for loop, I always really liked for loops because everything that you need is in one line. In a while loop, we had our initialization action, our Boolean check, and our update action on 3 different lines. A for loop works the same way, but it has the initialization action, the update action, And then our Boolean check all on one line.
That's nice.
Okay? So it tells us where we start, what we're checking, and then how we're updating that variable. Okay, and it's separated with semicolons. Those are semicolons.
So why would you use the other one? This one.
If you don't know how many times you want to execute. So you can use one or the other, vice versa, usually. Okay, actually you can use vice versa all the time. But a lot of times we'll use for loops when we know exactly how many times we want to loop. And we use for loops with arrays and different data structures where we want to iterate through that data structure a certain way. Where while loops we usually use when we don't know how many times we want to execute. Usually we use while loops when, we're getting some user input or reading from a file and we don't know how many lines are in the file, or we don't know how many times the user is going to input something. Okay? But, let's look at the flow chart for our for loop also, and how our for loop works. So it does the initialization action. And remember that action only happens once. When we come back up in our for loop, it does not set I equal to 0 again. It only happens once. The Boolean check happens each time, of course, just like the while loop. It checks to see if it's true. If it's not true, it goes outside of the for loop and continues on in your code. And then your update action always happens at the end of the loop. The I++ there is called your update action. It happens before the Boolean check, at the end of the loop, though. So at the end of each loop, you increment I by 1. And that's a common for loop thing to do. You don't have to always increment by 1. I could say I plus equal 5. I could have a method call there. I could have whatever I want there. But this is a common way to make a for loop. You'll see this for loop a lot. I equals 0, I less than something like length or 100, I++. And then we use that I variable kind of to count. So how many times will this loop execute? 100 times. You can see just by that for loop, you can look in there. From 0 to less than 100, you're incrementing by 1. It's going to count by 1 each time. It's going to go from 0 to 99. Okay, and that's 100 times. So you can tell right away how many times that loop's going to execute. It's a nice loop. And the slides do trace out the loop again. Okay. Now, you can declare I inside of the for loop. So inside of your for loop, you could write int I equals 0. In this example, they declared out I outside of your for loop. And there is a reason that you would want to do that. So if you declare I in your for loop, if you declare I right here, when I come out of my for loop, I is no longer there anymore. So if I wanted to use I out here, the variable I, I'd want to declare him out here. If I don't care about I anymore, I'm just using them right here, I would declare I right here. Okay? It's called locality of variables. They're local to where they've been declared. So he declared it out there for whatever reason. That's okay. He declares I. And then, it does the initialization action once. So it initializes it to 0. And then it does the Boolean check on every loop. So even in the first loop, it does that Boolean check. It's true, so it executes the loop body, which just prints out welcome to Java. Remember, at the end of the loop, it updates I, does the update action. Okay. It does the Boolean check again, because we're starting a new loop. Okay. Of course, 1 was less than 2, so it was true. It comes and prints welcome to Java. Does your update action. Now I is 2. So what's going to happen when we check the Boolean statement? He's false. Okay. All right. So things to remember, you only do this once. You do this at the end of each loop. And you check at the beginning of every loop. If it's true, you execute the loop, and if it's false, you skip the loop. Notice that we can't jump to other places in our code. We don't have any jump to line 55. In the olden days, they did have jump statements like that. Okay, and they got something called spaghetti code. Okay, and our loops, we always go back up to the top of the loop, and you only go back up to the top of the loop. You execute the loop, and when you leave the loop, you go right here. You're not allowed to jump somewhere else in our code. Okay, they got rid of that long ago. Okay, it made spaghetti code. It made horrible to debug, awful code. Okay, so they're very strict about where you can jump to in your code. When you start a loop, you start here, and when you end a loop, you start here. You don't get to go jump somewhere else crazy. Okay? All right, should we try a for loop? Let's try this for loop out. What time is it? We'll try this for loop out, and then we'll get through the rest of the slides here, and then we'll have time at the end to look at our homework. We should try our for loop. A lot of times, instead of writing loop in a for loop, a lot of times if it's incrementing with I, I'll just say, hey, this is I, and put a 0 here. I know it's kind of cheating, but that's okay. Okay. But we know that I is, starts out at 0, it goes to less than count I plus plus, so we know that it's incrementing like this. Okay? That's a common way to do it. And then we have the value number, or the variable number. And then we have the variable help. All right. And so the value of number starts out at 10. And the value of help starts out at 5. So even in the beginning, you say, okay, you do your Boolean check. You say I equals 0, so we set I equal to 0. Okay. I less than count. Wait, what is count?
Oh.
I didn't even realize I did that. Well, actually, what should we do? Should we just pretend that says I less than number?
Yeah.
Okay. Don't get confused, but we'll pretend it's I less than number. So then we can use this. Okay. So is 0 less than 10? Yes. So it even does the Boolean check. Remember, it does the Boolean check even at the beginning here. So number plus, so it drops into the loop. Number plus plus 11. Help equals number modulus 3, so the remainder of number divided by 3 is 2. Okay. And then we do our update action. Okay? So remember, you do your update action at the end. And remember that I cheated over here, and I made I my loop. Okay?
Wait, I think we did that wrong.
Help equals number modulus 3. Number was 11.
Oh, so it's the number that it changed to.
Because remember how your assignment operator works? You always do what's on the right first and put it in what's on the left.
But originally the number was 10.
Oh yeah, but this line of code happened first.
Oh, okay.
So it is executed in order. So number became 11 first. 11 was plugged in here. Our remainder always has to be 0, 1, or 2. But it's 2. Takes that 2 and puts it into help. Comes back up here. It doesn't do the Boolean check yet. It does the update action first. Then it does the Boolean check.
Wait, so it's 11 divided by 3,
Yeah.
and that number equals help.
Yeah, so it's number modulus 3. So it's the remainder of 11 divided by 3. The remainder as a whole number. So 11 divided by 3 is 9, remainder 2.
Right.
So the modulus operator returns the number 2, and you put that number into help.
So help is 5.
There's 2.
He was 5 up until this point. And then when we execute this line of code,
Oh, we just
we
replaced
put 2 into the help.
Okay.
Yeah. All It's kind of nonsense code, but that's okay. It gets our point across, right? All right. Well, who wants to do the next one? So we're right here in our code. I is equal to 1. In fact, we can erase these if we want to. Number is equal to 11, and then help is 2.
That's a question.
Yeah.
Will it ever end? Because it's going up by 1. So will I ever be greater than a number?
Oh, yeah.
So does it just keep going?
Actually,
on
that
and
is a
on?
good thing. Well, actually, we should do a couple more loops. But yeah, you start to see what's going on in there. Because I wrote this loop incorrectly, and then we just plugged the number in there, right?
Yeah.
And we did actually a big no-no in here. We actually made an endless loop. And that's good that you saw that. I is increasing by 1. But what is number increasing by? 1. Is I and 1, they're raising or increasing at the same rate. Is I ever going to become greater than number? No. If they're increasing at the same rate, then it's never going to be greater than number. And what happens in this case? An infinite loop. Okay. How can you fix the infinite loop? Well, there's certain ways. You can increase I by more. You'd have to rethink your whole logic of your program, really. You'd have to actually make a variable called count and increase him higher or faster than I. Okay, or don't increase count, keep count how he is, and so then I can increase and become greater than count. Okay. But for the sake of just executing another loop, what will our next loop be? Just so we can see what help is. Because we had some questions on help. So number plus plus will be 12. What is 12 modulus 3? 0, because it's 4 remainder 0. So what does help equal? 0. All right. We'll do it one more time just so we can see. Even though he is an endless loop, we'd be writing this forever, right? Yes. So number plus plus, what's 13 modulus 3? 1. And you'll start to see a pattern here. Can you see the pattern? Can you start? Yes. Next time, this will be at 14. It'll be remainder 2. 15, remainder 3. Oh, not 3. Sorry, 0. Can never be 3. Okay. But he will be an endless loop. I wrote that one wrong. It's okay. It's good to see our endless loops, and it's good that you can see that. That means, hey, we're understanding these loops, actually. You can see that that's a bad loop. Okay? All right. Note to self, I need to fix that. Ooh, this one. Should we save this one for next time? Yeah, we'll save this one for next time. We'll start out class. I'll bring my candy. We'll save this one. You can practice it at home, right? Yeah, this is lots of minus, minus, and plus equals. All right, so just to kind of sum up our loops, you guys don't have to learn this loop right away. We'll learn it when we get to arrays. We haven't gotten to arrays yet. Arrays are a variable composed of many variables. It's like a list. And then you would use a for each loop to iterate through an array. So if you want to look at arrays, they're in your book. I think chapter 7, maybe? What chapter it is? We'll eventually get to arrays, and here it's the data structure we learn in here. But we'll cover the for each loop when we get there. So for now, the loops that you should know is your while loop, your do while loop, and your for loop. Okay? All right. So common bugs are infinite loops. That happens more often than not. If your program in Eclipse just keeps running, if the red little button, you see a little red stop button, and there's no error message, that means it's continuously running. It means it's in an endless loop. Okay, and we can try that out today. We're going to try it out today. Subtle infinite loops is kind of a logic error. Sometimes your loop will terminate if you ask the user for some input, maybe some of the inputs will make the loop, terminate, but then others might not. Okay, so that would be a logic error. That happens a lot. Okay. Your book goes into off by 1 error, so sometimes if we use the less than symbol where we should have used the less than or equal, or vice versa, we'll execute the loop 1 too many times or 1 too few times. Okay, that happens a lot when we get to arrays, actually. We get an array out of bounds error. And then this happens all the time, so remember this error. Okay? If you write code like this, Eclipse won't have a problem with it. He'll say, yeah, that looks great. Okay? But what happens is this for loop executes, and it executes 10 times, but what does it do 10 times? It does this line of code 10 times. What does that line of code do? Nothing. So your for loop executes 10 times and does nothing. Then it comes here, and it executes this line of code once, and then it ends. So if that ever happens to you, remember, no semicolons at the end of loops. Okay, no semicolons, except for the do while loop. But the for loop and the while loop, no semicolons, just like your if statements. I call it short-circuiting your loop or short-circuiting your if statement. Okay? All right. And then we've already kind of talked about this. Choosing which loop to use, you can always use one loop or the other. So rule of thumb, if you don't know how many times it's going to execute, use a while loop. If you know it has to execute at least once, like a menu system, use a do while loop. Let's look at a break statement really quick. Do I put a break statement in here? Oh. I don't have an example of a break statement, but we could code one today. A break statement will break you out of a loop. So if you put a break statement in there, it tells the loop to stop immediately, go to the end of the loop, and not execute anymore. Okay? Which is important sometimes. If we're going to have an error, we can break out of our loop. Okay? All right. And I guess this is important, and we'll get the hang of this as we go along, is when you have repeated code, it pretty much screams at you that you should have a loop. So when you want to do something over and over and over again, the same thing, and you start copying and pasting your code, think loop, and then when we get even better, we'll think method. Okay, method or loop. All right, and we'll do a sentinel value one today. But what a sentinel value is, down here at the bottom of this slide, it talks about a sentinel value. And actually your programming problem this week for the loops has you enter in values until you hit a sentinel value. It's like a value that you're looking for, and when you hit like that value, you exit your loop. So you could say, enter in a negative number. I'll stop my loop. Or enter in the letter S. I'll stop my loop. Or type stop, and I will stop my loop. Okay, that's a sentinel value or a sentinel input. All right. I just noticed that these are fall 2005. So these slides actually started out. I have changed them over the years. But they started out as the Savage slides. Or the Savage book. All right. That's how long I've been teaching this, actually. All right. So let's try out our loops. We have a little bit of time left. Okay, we're going to try out our loops a little bit. We'll make an endless loop. And then we might as well just show the debugger today. I'm going to show you how to use the debugger in Eclipse to kind of show you how you can use it to look at the values of your variables as you're looping through your programs. Okay? And let me make sure we cover everything that we'll need to know in here. You have to use a sentinel value, so we can look at a sentinel value.
different eclipse that have mine too, Mars?
Mars is the most updated one, and here they did not update the eclipse since last semester or the semester before. And so we do have an older version of Eclipse. Note that you can have multiple versions of Eclipse on your computer. I would, on my computer at home, I do have the Mars version. I prefer the updated versions.
Also, I kind of like close that thing on the side.
Oh yeah, this right here. Yeah, you can close it. And if it ever goes away completely, or if any of your windows go away completely, you can always open them again if you go to Window, Show View, and then you can find all of your windows, okay, that aren't showing. So here's like the Package Explorer. All right, so if they ever go away completely, there they are.
Oh, does it show up on this one?
Window, Show View. Make sure there's or make sure you're hitting the right one, Package Explorer. There's like shortcuts right here too. All right, but let's go ahead and just make a test program, and you guys could use this test program if you want. So just a note, I know we're still beginning, but you should always name your classes with capital letters, right? Always our class names with capital letters. And remember that you could check mark the public static void main string arg, so it'll write that for us. So let's make a program that'll ask the user for some input. We'll just do one variable. It'll be kind of similar to your homework. And then we'll ask the user to enter in some numbers. And we're going to add them all up, and we'll tell them the average of their numbers. Okay? So just a simple program. So we should get in the habit of writing our date at the top of our programs. And this will just be a simple program to tell the user the average of the numbers they have typed in. And after test 1, we start getting into algorithms, and so then we'll start writing our algorithms at the top of our program. Okay. Because in our simple programs, sometimes, and actually this week, our programming problem might almost require an algorithm, us to write it down.
I'm excited.
When our programs start getting more complex, we need to start writing down our algorithms, our steps. That's what computer science is. It's the study of algorithms. Computer science is not just programming. Programming is implementing our algorithms. But that's how Google made all that money. How does Google make billions and billions of dollars? From their algorithms. Their searching algorithm is what made their first billion, and now they have lots of other algorithms they've implemented. Algorithms to spy on us. All right. Okay, so we're going to have an int variable. We'll call it total. Actually, we should make him a double. And when we want to add numbers to total, so we're going to use total, and we're going to add our numbers that the user types into total. So whenever you're going to do that, remember to initialize him to 0. Okay. We're going to get some user input, so we should start to remember this. And actually, this brings up an important point. I had some questions because on the lab, this was named a different name. I think I called it like scanner object. And we get used to seeing keyboard here or something else, but remember that we can name this variable anything that we want. We can even name him X. Okay? And remember that if we name him that, then that's the name that we use to get the input from. X is not a very good name. Okay. So we usually name him something like input or keyboard In that lab, I called him scanner object so that we would know that he was an object of type scanner. Okay. And if you got the red underlines like I do, remember to hover over them. And the quick fix in Eclipse will have us import that scanner java.util. Remember that it writes this at the top of our program for us. So it includes that class library. All right, so now let's make our loop. Actually, let's get some user input. Let's output to the user and tell them what to do first. It's always good to have some kind of instructions print out. Please enter in numbers. And I will tell you the average. Okay, so just some simple output. Otherwise, it'll just be a blank console waiting for us to input stuff. So sometimes it's good to have some kind of output. Now, in this type of loop, which loop should we choose? And we can go back and forth, and we can choose any of them. But what makes sense? What kind of loop makes sense here? Do we know how many numbers the user is going to enter? If we said, please enter in 10 numbers,
How about a while loop?
and we made them enter in 10 numbers, then a for loop would work great. But because we don't know exactly how many numbers they're going to enter, a while loop is good. Okay. In fact, actually, let's start out with 10 numbers. So let's start out with 10 numbers, then we'll go on to the while loop, because then we need a sentinel value. This will be easier to program if we know exactly how many numbers they're going to enter. In fact, let's not do 10, let's do 5, so that way it'll go faster. It'll be 5. Please enter in 5 numbers, and you're going to tell them the average. So then a for loop, a for loop would work great, because we know exactly how many times we want to loop. Okay? So usually these loops are, kind of look the same. We know how many times we want to iterate or go through our loop. It's called iterating through your loop when you go through your loop. If we start out at 0, go to less than 5, and increment I 1 time, that'll happen 5 times. Note that we could have started at 1, go to less than or equal to 5, and incremented I 5, But this is a more common way to write it. Okay, a lot of programmers will start at 0, go to less than the number they want to go to, and then add 1 each time. They start counting at 0. All right. Remember, no semicolon right here. No semicolon.
Did you add that bracket?
Oh yeah, I added this curly bracket because this is going to be my loop body. If I'm only doing one thing in my loop, then I don't need curly brackets, but because I'm going to do more than one thing, actually we are only doing one thing, aren't we? All right. So we'll say plus equal, and then we'll get that number from the user. Notice Eclipse helped me a lot out with that. He said, hey, you want to choose the next double because total is a double. Now remember, when we're doing averages, this is a common algorithm to get averages. And when you're doing an average of something, like in real life, when you want to average something, what do you do first? Yeah, you have to add up all the numbers first. Then after you're done adding up all the numbers, you divide. So remember that a lot of times, a lot of people will put the division in here, or they'll even write another line of code in their loop. Or they'll even make another variable. Actually, you guys don't have to write this part. Or they'll even make another variable called answer. And this answer will give you the right answer. But this is incorrect how they've written their loop. Because it's finding out the answer on each loop before you've even figured out what the total should be. So remember that when you're writing these things for averages, always do the division part of your average outside of your loop. And it makes more sense because it's after you found the total. Okay, so this is the way that you should write it. Now you can either say total equals total divided by 5 or total divide equal 5, or you can make a new variable called answer and use answer to store your answer. So there's lots of ways you could program this, right? So the way I did it, so just so you know, I did add that variable answer. You had to declare them up here. And then after the for loop is finished and we figured out our total, then we figure out answer. We figure out the average, which is, I guess I could have named him average too, right? Answer. So we do our input, our processing, and now we need to do our output. We could say the average is, and then we print out what our answer is. Cool. And if you run him, he will work. Do something that you know what the average is so you can see that he works correctly. And then you could try it for larger numbers. So when we're testing our programs, it's good to test it with different kinds of input. So it's good to test it with some input where we know the average. So 1, 2, 3, 4, 5, I know the average is 3. And then it's good to test it again with some different inputs. Maybe like 1, -8, 5, 0, 2. Actually, it gets the wrong answer. Wait, is that the right answer? Actually, that is the right answer for the average. I just happened to enter in numbers that made the average 0.
Oh.
All right. So you figured it out. Good.
I was trying to figure out what I did wrong.
Good.
Oh, it's still underlined.
And I don't think we're going to get to the debugger today, so I guess we could save the debugger till later. Oh, you got all tangled up. I guess some people would demand that you do that. Right? I guess it is good programming practice. I probably should promote this more. Just remember to write this at the very end of your program. Okay? It's just telling you that that object is open and that he should be closed. It's whenever we read and write from files. We actually do learn to read and write from files in this class. We have to always remember to close our files properly.
So from now on, you'd like us to put input dot.
Yeah, I don't really mind all that much, to tell you the truth.
So
But
if we forget, it's not going to be a.
yeah.
Okay.
Yeah. I really should. All right, let's just change this so that they can enter in any amount of numbers that they want. Instead of saying, hey, you have to enter in 5, notice our program will not work if they enter in 6. It won't work if they enter in 3. It only works if they enter in 5, which is not a very adaptable program. So let's change it to a while loop. So what I'm going to do is you can comment out your for loop so you can still see how he works compared to your while loop. Oh, I should show you how to do a mass comment.
Was it a while loop?
This was a for loop.
Oh, right.
Yes. So if you wanted mass comment or comment out a section of code, you can do /* at the beginning of your comment section. And then */ to end your comment section. And that's a common way to kind of comment out a block of code. So remember that this code will not execute anymore when it's commented out. Yes, Douglas. Oh, okay. I'll be right there. Let's do this while loop and then I'll come help you. All right. So you can still, if it's not working for you, I can come around and help you debug, but still continue kind of working along with me, okay? All right. So we're going to change our output statement there. Please enter in, instead of 5 numbers, we'll say some numbers. And I'll tell you the average. Okay. We're still going to use the same total variable, and we can still use the same answer variable. But now we're not going to hard code a 5 here. What are we going to put right here? Huh? What should we put right here? Not I, because we're not going to have I anymore. I guess we can make a variable I. Maybe that's what you mean. We need to keep a count variable. So we need to make a new variable and keep count of how many numbers they're actually inputting so that we can get the average. So I'm actually going to make a new variable and call it count. And he could be an integer. And we'll start him out at 0. And then every time they input a number, we'll increase him by 1 and we'll keep count so that way we can find the average. That makes sense, right? Because they could enter in 3 numbers, they could enter in 100 numbers, you know, so I don't know who would want to sit there and enter in 100 numbers, but it could happen. They could enter 1,000,000 numbers. If you entered in 1,000,000 numbers, 1 each second, 24 hours a day, 7 days a week, how long does it take you to count to 1,000,000? How long would it take you to enter in 1,000,000 numbers? That's extra credit. Figure that out. Like if you wanted to enter in 1,000,000 numbers in this program,
Okay.
and you never slept,
Okay.
and you entered in 1 per second, so 24 hours a day, 7 days a week, you sat there and you entered in 1 number every second. So how long does it take you to count, you know, to 1,000,000 pretty much? How many seconds, you know? Or well, yeah, seconds, but how many days, how many weeks is that? How many months?
So we go into months.
Yeah. To count to 1,000,000, 1,000,000 is actually a really large number. We've gotten used to talking in millions, but 1,000,000 is actually a really big number.
11.5 days.
So he said 11.5 days.
No sleep.
That's 1,000,000.
No sleep.
No sleep. Okay. How about 1,000,000,000? It's good to know these things. So we talk in billions. Gigabyte is 1,000,000,000. Giga, that's 1,000,000,000. We talk in billions. We're billions of dollars in debt. Well, actually trillions. How long does it take to count to 1,000,000,000?
I need a bigger.
Okay, we'll start writing this too. Okay. Well, anyways, okay, so we're going to have a while loop. All right, so let's think about how we want to get these numbers and then where we want to stop. We need some way to stop our loop. So a common thing to do is to tell the user to enter in a sentinel value when they want to stop. Okay? So we could have them enter in a negative number, or we could ask them, say, hey, do you want to loop again, and then check it. Which way do you guys want to do it? Your homework actually asked for a sentinel value. Want to do a sentinel value? Like your homework? Okay. So I'll tell you the average, and we'll tell them to enter a negative value when you want to stop. So we're only taking the average of positive numbers. That's okay. All right.
For billion, it will take you 11,774 days.
Divided by 365.
That's 31 years.
Yeah. 31 years, yes. That's never sleeping. All right.
You died like in that month, I think.
Yeah, I know, right? All right. So actually, this loop kind of screams at us that it should be a do-while loop. Should we make it a do-while loop? So let's make it a do-while loop because we need to get at least one input for it to function, right? And there's different ways that you can do this sentinel value thing. All right. So we'll get our input. Actually, let's do it we'll make a logic error and then we'll fix it. So we made our while loop, we did our do while loop. When will we know when to stop? When our input's a negative number. Okay. How will we know our input's a negative number? When we're doing it this way, we're adding it straight into total and not storing that input anywhere. So it almost makes sense that we should have an intermediary variable here to store our value of our input first and then add it to total. Okay. Okay. Actually, we should make him a double since we're inputting doubles. So we're making this temporary variable holder that we can check. Okay. And then we'll add that number to total. Oh, shoot. And actually, this is a good thing. What is it having a problem with here? Oh, no, we need count in here, too, so we're going to do a count plus plus. Every time they enter in a number, we want to add 1 to the number. But notice it doesn't know what number is down here in the while loop. And the reason it doesn't know what number is down there in the while loop is because we declared it in the loop. And this is a good example of locality of variables. If you declare this variable in this loop, so in between these curly brackets, when it gets to the end of this curly bracket, it throws this number out with the trash. It's called the garbage collector, actually. The garbage collector comes and gets number and reclaims that memory. So if we want number to exist outside of those curly brackets, we have to declare him outside of the curly brackets. So in other words, we need to declare number up here. So we need to make that variable number up here so that we can see him outside of the loop. So we get rid of the declaration down here and we declare him up here with our other doubles. So now we're storing that input into this variable called number. We're adding number to the total. We're keeping count. And if number is ever negative, then we leave the loop. If you really know how loops work, you should start to foresee that we're going to have a logic error in here. Can you start to see the logic error maybe? And maybe we need to run it a couple times for you to kind of see what kind of logic error. You can run him. Oh, actually, we need to change one other thing before we run him. Total is not going to be divided by 5 anymore. What's total going to be divided by? Count. Now, number is our temporary holder. So count just adding up how many numbers we've typed in so that we can find the average. Total is holding the total. It's adding all the numbers up. And then number is just kind of a temporary placeholder so that we can check to see if he's greater than 0. He's just, he's holding that input for us so we can check it down here. Now you will get a logic error. Go ahead and run him. And when you enter 1, 2, 3, 4, 5, oops, dang it. 1, 2, 3, 4, 5. How do I get out of the loop? You put -1, right? And then what should be the average of 1, 2, 3, 4, 5? The average should be 3. But it gives me the average as 2.33333333. Yes, very good. When I entered in -1, what happened? It added -1 to the total. And then it increased my count. So when you do a sentinel value, you have to check for that sentinel value right after you type it in. So we need to check for that sentinel value right here. And there's different ways you can go about, fixing this. One way is you could say if the number is less than 0, this is an example of a break statement, you could break. This is a common way to do it, to check for a sentinel value. Check right away. If it's a negative value, get me the heck out of this loop. And don't add them to total. Don't add it to count. Just get me out of the loop. Okay, so that's one way that you could do it. What's the other way you could do it? You could do a check right here, and you could say, okay, if number is greater than or equal to 0, then do these 2 lines of code. So there's 2 ways you can check. You can check, say, hey, if you're less than 0, get me out of here. Or you can say, okay, if they enter in a negative number, I'll check it here. If it's negative, skip these, and then it'll get out down here. Okay. And if it's positive, it'll execute these. So that's 2 ways you can use a sentinel value to kind of get you out of the loop. Which way do you like better?
I like break.
Yeah, most students like it is cleaner, I think. Okay, to do it that way. But both ways will help. It'll fix that logic error. Wait, question? Yeah, you don't even need it. So notice that, actually for this one you do. But if you do it this way, this isn't even needed anymore. And that's good that you see that, okay? So in other words, what he's saying is, if I wrote my code this way without this loop, and I check my sentinel value this way, and if it's less than 0, I break out of here. Actually, you can write while true in here, and it'll work the same way. Because we know that that'll always be true. And actually, you'll see a lot of code online, or you'll see some code sometimes, and they actually write while true. This looks like it's an endless loop, but it's not, because we will get out of it right here. So sometimes a lot of people will write their code this way, but sometimes for beginning programmers that's confusing. So you can leave it this way, and that's fine too. But that's good that you saw that, hey, it never actually gets to be false here. Because when it's false, I get out of there and I don't even check it. Okay, so that's 2 ways you can do sentinel values. Okay. Or use a sentinel value to get out of a loop, a sentinel negative value to get out of a loop. Okay. And you can use either way in your programming project, your loop programming project, for the grades.
Do you mind scrolling down?
Oh, yes, scrolling down. All right, and I think that's a good place to end class today. Remember to read in your textbooks, okay?